Hi, I'm Jeremy and this is Chemistry of Questionable Quality. You've probably seen me commenting on your chemistry videos if you make them, or you've probably seen my comments around. So tonight we're going to start our aminoguanidine project. We're going to make it 3 different ways over time, obviously in a series of videos. We're going to do it all from like OTC stuff you can buy at like Walmart and the dollar store, going from starting materials all the way to aminoguanidine bicarbonate. So tonight we're going to be doing the calcium cyanamide synthesis. In this can I have some calcium hydroxide, some urea, and a pinch of silica gel to help with the foaming. So, I'll have to edit this out. So what we're going to do is we're going to heat this strongly for a moderate period of time. It's going to take about a couple hours. And we're going to slowly ramp the heat up. And as we do that, the urea decomposes into cyanuric acid, and then the calcium hydroxide reacts with that, making calcium cyanate, which is an intermediate for aminoguanidine. We then convert the cyanamide to, So basically what the reaction is we're heating this can with some urea and some calcium hydroxide in it, a little pinch of silica gel to deal with foaming. And over the course of like an hour or two, closer to 2, we're going to ramp up the heating. And eventually this will melt. It'll give off a bunch of ammonia, which is why you really have to do this outside or in a fume hood. I've filled my house with ammonia before. I don't want to do it again. But yeah, so the urea loses ammonia, decomposes into cyanuric acid. That combines with the calcium hydroxide and makes calcium cyanamide. So calcium cyanamide is then reacted later in another video with hydrazine sulfate in order to form aminoguanidine. So over the course of the series, we're going to make aminoguanidine 3 ways. We're going to make our own guanidine nitrate, turn that into nitroguanidine, and then we're going to do a zinc reduction of that. And we're going to do the electrolytic reduction, which I don't believe is on YouTube anywhere. At least I haven't found it, and I watch a lot of chemistry videos, as you probably notice if you watch chemistry videos too. I comment on everything. So, all right. Yeah, so let's get to it. We're going to use a $15 Walmart hot plate, some aluminum foil to help capture the heat. We have a foil cap on this with some little pinholes in it, and that'll help the ammonia leave, help control the foaming if it gets up a little too high, and it keeps water out, which can interfere with the reaction. All right, let's get to it. Oh, I will have reaction schemes and everything like that for people who are really interested in that. I'll put up a still or something like that. I'll get ChatGPT to make it or some shit. Okay. Okay, so we have this on the hot plate. We're going to tent some aluminum foil around it. We burned the, or I, not we, I'm not talking in the third person like some kind of psycho. So I burned the lining out of the soup can because all cans have a plastic lining, and I just don't want that shit in my product. We're going to use some aluminum foil, like I said, to make a tent around it and concentrate the heat. I ran out of aluminum foil, so I would normally use more for this. But we should be able to get a pretty good coverage here. And yeah, I've gone through several of these hot plates. They're $15 at Walmart. I have absolutely destroyed some. I had a huge overflow making nitric acid like a couple weeks ago, and I am shocked that this thing still works. But here we go. I will include the temperatures in the reaction scheme still and all that stuff. So, all right, we have a infrared temperature gun to check our temperature. It is currently really hot out. That's the ambient temperature right now. I live in Arkansas. It's hot, it's humid. This time of year is, I love it, but it kind of sucks at the same time. Alrighty then, let's let this start to heat up. All right. Okay, we're starting to get some ammonia evolution. Yeah, I'm not wearing my safety glasses. I'm a piece of shit. I get it. So something I have done here is I have used a Sharpie. Oops, let's not knock everything over. I've used a Sharpie to make some black marks on the lid of the can and about halfway down the side and down here, because anything reflective is like dog shit for getting proper temperatures with an IR thermometer or temperature gun, whatever you want to call it. So, yeah, I can definitely smell the ammonia. This certainly isn't something you want to do indoors. And it may foam up and get ruined. That happens to me sometimes. But so far, it's doing what it's supposed to. We've got a reading of 25.7 on top. That seems weird. Down here, we've got 128. And up here, we have 47.9. That seems more accurate. So, all right. We'll allow it to melt. It does melt as it's heating, and it does foam a bit, which is why I put the silica gel in, like I mentioned. Break up the bubbles. That doesn't interfere with the reaction, and it won't interfere like at any step along the way. But you can also like remove it if you really want. But I ran it through a blender, and I ran everything through a blender to make sure it was well combined. So yeah, that's not coming out. All right, be back in a bit. Okay, I'm just gonna hold the camera for this, but it's giving off a lot of ammonia. I just wanna see, give it a look, give it a stir. It's still not liquid yet. It's been a while, but it's liquid underneath. It's giving off a considerable amount of ammonia. It fucking stinks. But all right, we know it's working. That's really all we needed. All right, see you in a bit. It's 3 o'clock in the morning, so we're done. And it took a lot longer than I expected to come up to temperature. It's sort of a pale brown color. I don't know if you can see that. It's kind of dark in here. It's like a pale browny yellow. I'm colorblind, so take that with a grain of salt. But yeah, we're done. So we'll let that cool down. The reaction's done, at least. And we will wait till tomorrow and chip it out of the can, and I will get back to you. Okay, so I ran out of storage space there filming this, but it's foaming. We added another pinch of silica gel to keep the foam down, and just waiting for it to stop evolving ammonia. This is our dog Lizard. We had a 3-year-old at the time, so that's where the name came from. She likes to go out at night and get in fights. She's half corgi, half chihuahua. It's 3 o'clock in the morning, so we're done. And it took a lot longer than I expected to come up to temperature. It's sort of a pale brown color. I don't know if you can see that. It's kind of dark in here. It's like a pale browny yellow. I'm colorblind, so take that with a grain of salt. But yeah, we're done. So we'll let that cool down. The reaction's done, at least. And we will wait till tomorrow and chip it out of the can, and I will get back to you. Okay, so here's our calcium cyanate. Apologies for repeatedly saying cyanamide. That's the next step. I'm not going to show like breaking this out of the container. It's not going to be too tough. But basically after this, you throw it in a fire, like a wood fire, charcoal, kiln, whatever, in a sealed container with a pinhole to allow CO2 to get out, but oxygen not to get in, and that'll take you to cyanamide. This is cyanate. All right. Hope you guys enjoyed it. This is really not a super big instructional guide. If you don't know what's going on here and all the processes, this probably isn't for you.
But for people who are capable of looking up exactly like amounts, like stoichiometry and stuff like that, then that's more who I'm looking for.